A very good afternoon, everybody. Myself, Mamta here, and I'm from GPC Khuni Majra. I'm a lecturer in computer department. Today, my topic of discussion is the definition of circle and the algorithm for drawing the circle in computer graphics. Let's go through the lecture that the topics we will be covering through. First of all, we will be defining what is a circle. Then we'll be finding the scan conversions of the circles, simple circle algorithm, circle drawing algorithm, fast circle algorithm, and midpoint circle algorithm, Bresham's algorithm, and last topic will be the summary, the topics that we will be teaching. And these are the topics which we will be going through. Means all these are the algorithms which are used for drawing the circle. First of all, defining a circle. A circle can be divided into 360 degrees. Everybody knows when looking at the circle, it is obvious that the circle is symmetric with regard to the coordinates axis like x axis and y axis, and the axis of quadrants, as well as function which is x is equal to y and x is not equal to y. Means a circle is having a symmetry according to its x coordinates and y coordinates. It holds for the circle with a center that is 0 0, that if a point x y lies on the circle, means it means the other points like y x, y minus x, x minus y, and minus x minus y minus x, and minus y x and minus xy, all these points will also be lying on the circle. Means if x and y is the x coordinate and y coordinate, it lies on the circle, then all these points will also be lying on the circle. For defining all the points on the circle, it is sufficient to compute 1/8 of the arc of the circle, that is the arc which ranges from 0 to 45 degree. There is the naive algorithm for circle which says if x square plus y square is equal to r square, where r is the radius, x and y are the x coordinates and y coordinates of the circle, then the simple algorithm will be to find x which starts from x minimum and goes to x maximum. Means the value of x lies between x minimum to x maximum, and then y will be the square root of r square minus x square. Then we will be drawing the pixel of x and y. The location, if we will be finding the value of x and y, then we can draw the pixel at x location and y location. This is the algorithm which works only by the octants and when it uses symmetry of the circle. Next comes the scan converting circle. Means another method to find the drawing of the circle. Explicitly, if y is the function of x, then y will be equal to plus minus r square minus x square under root. Usually we draw a quarter circle, that is this is the quarter circle which ranges from 0 to 90 degree, by incrementing the x value from 0 to r and in unit steps and solving the plus y for each steps. We will be incrementing the value of x from 0 to r, which is the radius of the circle or the quadrant, and according to the values of x, we will be finding the values of y for every step of the x. The parametric equations for finding the value of x and value of y will be x is equal to r cos theta and y will be equal to r sin theta. Means by stepping the angle from 0 to 90 degree avoids large gaps, but it is still insufficient method to draw circles. Here you can see this is the pixel location which is not coming on the symmetry of the circle. Some pixels are coming below the symmetry and some pixels are going above the symmetry of the circle. So, implicit method will be function of x is equal to x square plus y square minus r square. If f of x and y is equal to 0, then this pixel is on the circle. If f of x and y is greater than 0, it means the pixel is outside the circle, and if f of x and y is less than 0, then it is inside the circle. Next comes simple algorithm for drawing circles. Since we know the equation of the circle for radius r, which is having center 0 0, is x square plus y square is equal to r square, where x and y are the xy coordinates of the circle and r is the radius and 0 0 is the center of the circle. And obvious choice will be to find out the value of y, which is the square root of r square minus the x coordinate square, means the square root of r square minus x square in plus minus values. So, the value of x will be lying between the positive value of the radius and the negative value of the radius, means x lies between minus r and r. This will be working, but this is inefficient technique because of the multiplications and square root operations. So, to find every pixel on every symmetry of the circle, there will be multiplications, lots of multiplications and lots of square root equations will be found. ठीक है? It is also used to create large gaps in the circle for the values of x which are close to r, means these are clumping for x near 0. You cannot find the accurate pixel which will be coming on the symmetry. Some pixels will be coming above and some pixels will be coming below the symmetry. So, there are large gaps between the two adjacent pixels. So, this technique is also not efficient for circle drawing. So, a better approach which is still inefficient but avoids the gap is to find out value of x is equal to r cos phi and the value of y which is equal to r sin phi, and then the value of phi takes the value between 0 degree to 360 degree. Next method, which use 8-point symmetry technique for drawing circle, is we only need to calculate the values on the border of the circles in the first octant. Here you can see there are octants of the circles, 8 octants of the circle, and at every octant of the circle we have to find the values on the border of the circle. Like this is the value of b and a in this octant, this is the value of a and b in this octant. Similarly, we will be finding 8 values in 8 octants on the borders of the 8 octant. So, we assume that a circle of radius r with center 0 0 is having the procedure of finding the points on the circle, that is procedure is circle underscore points the value x and y with integer. Then begin, you have to plot x and y, yx, y minus x, x and minus y, minus x and minus y, plot minus y minus x and plot minus y x and plot minus x minus y, means in every quadrant, in every octant you have to find the positive and negative values of the x and y coordinates on the circle. Then there comes the fast circles. What are the fast circle? In which we consider the first octant of the circle of radius r, which is centered at origin, that is 0 0. This is the center, this is the origin of the circle, this is the radius r of the circle, and we begin by plotting point r0 and end when x is less than equal to y. We start from r is equal to 0, we proceed until we reach the point when x is less than y. So, the decision at each step is whether to choose the pixel directly above the current pixel or the pixel which is above and to the left. So, we can choose the pixel which are either above the symmetry or the pixels which are below the symmetry. Here you can see pi, that is xi and yi, this is the current pixel, you can see this is the pi, that is xi, and yi, this is the current pixel, and ti, that is xi, and yi plus 1, this is the pixel directly above the symmetry, above the quadrant, and si is the pixel which is above and to the left. So, this is the location, showing the location of the pixel above the symmetry. Some pixels are lying on the symmetry, these are the pixels where x is equal to y, and there are some pixels which are lying below the symmetry and some pixels which are lying above the symmetry. This is the decision variable technique which is used for drawing fast circles. Here you can see f of x and y, as we know, is equal to x square plus y square minus r square, which is equal to 0. To find the value of f at xi minus half plus e and yi plus 1, and it is equal to xi minus half plus e square plus yi plus 1 square minus r square. We have to put the value of x coordinates and y coordinates in this equation to find the functions of x and y. You will be finding this value, which is the equation function of x and y, where E is the center of the location. Then di is equal to f of xi minus 1 by 2 comma yi plus 1 is equal to minus 2 xi minus half e minus e square. So, if e is less than 0, then di is greater than 0. So, we can choose the point S, which is xi minus 1 comma yi plus 1. You will be finding the value of xs as in the form of x coordinates and y coordinates in the condition when e is less than 0 and d of I is greater than 0. And if e is greater than equal to 0 and the value of di is less than equal to 0, then we will be choosing the value of t. Means this is the pixel which is lying above the symmetry, this is the pixel which is lying below the symmetry, and E is the pixel which is lying on the symmetry of the quadrant. So, the value of t will be obtained if the value of E is greater than equal to 0. The value of S will be obtained when the value of E is less than 0. So, these are the locations of the pixels by using decision variable. So, the initial value of di is d0, that is r minus half square plus 1 square minus r square. Then it is equal to 5 by 4 minus r, that is 1 minus r can be used if r is an integer. When you are finding the pixel at point S, then the value of x and y is chosen and the value of di will be di plus 1 is equal to di plus minus 2 xi plus 1 plus 2 yi plus 1 plus 1. Then at the point t, which is the pixel which is found when the value of E is greater than 0, the value of di plus 1 will be di plus 2y plus 1 plus 1. So, this is the algorithm which is used to draw fast circle, that is begin a circle x is equal to r, y is equal to 0 and d is equal to 1 minus r. Repeat this process. The circle underscore points x and y is equal to y plus 1. If d is less than 0, then d is equal to d plus 2 star y plus 1. Otherwise, x is equal to x minus 1 and d is equal to d plus 2 star y minus x plus 1. Then and you have to repeat this procedure until x is less than y, and this is the end of the circle. With this technique, with this algorithm, fast circle algorithm, you will be drawing the circle, you will be finding the location of the pixels of the quadrant until you reach the value of x which is less than y. This is the procedure which we had already used. To begin, you have to plot every coordinate xy, yx, x minus y minus x and all these 8 coordinates on the 8 quadrants of the circle. This is the 8-way symmetry which is showing first quadrant, this is the second quadrant, third quadrant, fourth, fifth, sixth, seventh and eighth. There are 8 quadrants and every quadrant is showing the value of x and y in plus value and minus value. So, you can write the pixel of x, y and value, pixel of y, x and value, y minus x and value, x minus y and value and so on. These are the circle points, mean you are finding the location of the pixels on the quadrants at the borders of the symmetry of the quadrants of the circle. This is another method, another example. You can see x and y are the xy coordinates in this quadrant, y and x are the yx coordinate in this quadrant. This is the radius and this point is the radius over under root 2. So, at every quadrant location, this is the 8-point symmetry, 8-way symmetry of the circle, you can find x and y coordinates. So, the first thing we can notice to make our circle drawing algorithm more efficient is that the circle which is centered at 0, 0 have 8-way symmetry. Next comes the midpoint circle algorithm, which is another technique to draw the circles. This is this is the diagram which is showing the location of the current pixel, previous pixel and the choice of the next pixel. The algorithm is as following. You have to find d old, that is the old diameter is equal to function of xp plus 1 comma yp plus 0.5. If d old is less than 0, then E is chosen, that is the pixel which is above the symmetry, and d new will be f of xp plus 2 comma yp minus 0.5. Then d old plus 2xp plus 3. These are the values which will be found for finding the location of the pixel E. If d old is greater than equal to 0, then SE is chosen, that is the this pixel which is the location of the pixel below the symmetry. So, the value of d new will be fxp plus 2 comma yp minus 1.5 and the value of delta SE will be 2xp minus 2yp plus 5, where xp and yp is the location of the previous pixel. So, initialization is to do d init is equal to 5 by 4 minus r, which is equal to 1 minus r. Further, this is the algorithm showing the midpoint circle drawing technique. Here you can see these are the x axis and y axis having some x coordinates and y coordinates. This is the first octant, this is the second octant. These two octants are ranging from 0 degree to 90 degree. First octant is generated by 8-way symmetry technique and second octant is generated by this algorithm, which is midpoint algorithm. The algorithm is as following: void midpoint circle int radius comma int value, then assume the center of the circle is at origin, that is 0 0, you have to find int x 0, int y is equal to radius, then int d is equal to 1 minus radius. Circle points are x, y, comma value. While y is greater than x, you have to do, if d is less than 0, then d is equal to d plus 2 star x plus 3. Then this is the selection of the pixel E which will be rising above the symmetry. Otherwise, find out the pixel SE whose value will be d is equal to d plus 2 star x minus y plus 5. Then keep on repeating this process until the value of y is greater than x. Then these are the values of circle points of x and y with their value. Next comes the Bresson's algorithm, in which there is a choice between the two pixels, means either the circle is drawn with pixel above the symmetry or the circle is drawn with pixel below the symmetry. There can be pixels which are lying above the symmetry, there can be pixels which are lying below the symmetry. So, by using Bresson's algorithm, you can choose which pixel is to be taken. Bresson's algorithm use midpoint technique. Here it says, if the midpoint between the pixel is inside the circle, then E is closer, so we will be drawing E, and if the midpoint is outside the circle, then SE is closer, so we will be drawing SE. So, we will be drawing E if the midpoint is E is closer, and if midpoint is outside, then SE is drawn. Bresson's algorithm says, if d is the error function, that is x square plus y square minus r square, then compute d at the midpoint. If the last pixel is x and y, then E will be x plus 1 and y, and SE will be x plus 1 y minus 1. The value of x will be above the x coordinates and the value of y will be below the y coordinates y axis when the SE pixel is chosen. Hence, the midpoint says the functions are f x plus 1 and y minus 0.5. So, to calculate dxy is equal to, put the value of x here, put the value of y over here, then you will be finding the value of d. If it is less than 0, you can draw E. If it is greater than 0, you can draw SE pixel. So, what are the techniques for updating the errors? In each step, go to E or SE, that is increment the value of x by 1 and d by 2x plus 3. If I goes to SE, then you will be doing value of x by 1 and the value of y will be decreased by 1. So, the value of d will be minus 2y plus 2. To multiply 2 additions per pixel, can you do it better? So, this is the error, this technique is little bit erroneous, having multiple multiplications and multiple additions to find every pixel on the symmetry. So, we can extend it to some other functions, like midpoint algorithm is easy to extend to any curve which is defined by function f of x and y which is equal to 0. If the curve is polynomial, it can be reduced to only additions using n order differences. How to draw the circle? This is the x axis, this is the y axis. You can see this is the outline of the circle by using Bresson's algorithm, showing x coordinate is equal to 17 and y coordinate is 0 on x axis, and x coordinate is 0, y coordinate is 17 on the y axis. So, these are the locations of the pixels on the outlining of the circle. So, this is another technique to find, this is another example in which we will be finding the location of the pixels on the symmetry of the circle. It uses, that is same 8-fold symmetry, that is 8-way symmetry, in which you can find the location of the current pixel, location of the previous pixel and choices for the further pixels. Circle drawing technique which uses first method, that is x minus xc is square of x minus xc plus square of y minus c is equal to r square. So, the value of y will be yc plus minus r square minus xc minus x square, that is xc minus r goes to xc plus r. The value of y will be ranging from xc minus r to xc plus r. The another method is 8-way symmetry method to find the values of x coordinates and y coordinates on the border of every quadrant with the degree from 0 to 45 degree. So, this is example of this is another midpoint circle algorithm in which we have input radius r, center xc, yc, and we will be obtaining the first point on the circumference of the circle having center 0 0, that is origin. So, the first point will be x 0 y 0, that is 0 and r, that is on x axis the value of x is 0, the value of y is r. To calculate the initial value of the decision parameter as p naught is equal to 5 by 4 minus r, and at each x k the position, the starting at k is equal to 0, perform the following text. If the pk is less than 0, the next point along the circle centered on 0 0 will be xk plus 1 yk, and pk plus 1 is equal to pk plus 2xk plus 1 plus 1. Otherwise, the next point along the circle will be xk plus 1 yk minus 1. So, the value of pk plus 1 will be pk plus 2xk plus 1 plus 1 minus 2yk plus 1, where 2xk plus 1 is equal to 2xk plus 2 and 2yk plus 1 is equal to 2yk minus 2. Determine the symmetry points in the other 7 octants. This is the location of symmetry points on the first octant. Similarly, you can repeat the same procedure to find the points on the other 7 quadrants. Move each calculated pixel position x and y on the circular part having center xc, yc, and then plot the coordinates value, that is x is equal to x plus xc and y is equal to y plus yc. So, repeat the step 3 through 5 until we find x is greater than equal to y. So, this is midpoint circle algorithm technique which is used to find the values of the pixel points on the circumference of the circle by dividing the circle into 8 octants. Example of, you can see here is the example of midpoint circle algorithm. Given a circle with radius r, that is equal to 10, we find the midpoint circle algorithm by determining the position along the circle octant in the first quadrant, that is from x is equal to 0 to x is equal to y. The initial value of the decision parameter will be p naught is equal to 1 minus r, that is 10 minus 1 minus 10, that will be equal to minus 9. This is the initial value of the decision parameter. For the circle having center at origin, that is 0 0, the initial value is x 0 y 0, means at the origin the value of x is equal to y, that is this is the value x 0 y 0. The then this is 0 and this is 10, this is the value of x, this is the value of y, and the initial increment terms for calculating the decision parameters are 2x0 is equal to 0, 2y0 is equal to 20, that is x0 will become again 0 and y0 will be 20. So, these are the decision parameters value and positions along the circular path which are calculated using midpoint method. Given the value of k and the value of pk, you can find the value of xk plus 1, yk plus 1, 2xk plus 1 and 2yk plus 1. So, these are the locations of the pixels according to the midpoint circle algorithm. Then there comes another simple example of circle drawing algorithm. This is the location of the pixels on the symmetry of the circle, which is drawn by applying the method y naught is equal to 20 square minus 0 square under root, that is equal to 20, y1 is equal to 20, y2 is equal to 20. Similarly, y19, y20 is equal to 6 and 0. These are the values of the y coordinates which are calculated according to the values of x coordinates.